Let's talk about subsets now. So A is a subset of B is written this way. A is a subset of B. And this is not like a letter C. This is a flattened out C. So we should differentiate. The book differentiates nicely with the font they use. If you have trouble running into a problem that has a C and your symbol looks like a C, maybe make a substitution, use a different letter. But if you have A is a subset of B, that means set B could have elements 1, 2, and 3. A, which has elements 1 and 2, would be a subset. A, which has none of those elements, 0, an empty set, a null set, that is also a subset. Okay? Or it might just have one of them, A equals 3. That's a subset. Okay? A equals 3 is a subset of that set. Okay? If you had the case of A equals 1, 2, and 3, okay, then we would say if A equals B, okay, then that's a subset also. Okay, if A equals 1, 2, and 3, okay, so A is a subset because it has these elements, all of them in fact, but every one of these elements is from here, so it is a subset. Okay, so that is a subset that's written this way. Okay, we have a thing called a proper subset. A proper subset. The proper subset excludes this case. Okay, a proper subset excludes A equal B. Okay, a proper subset excludes that. Okay, so when you say A is a proper subset of B, it does not allow. Okay, we could say like this: if A, let's rewrite what I just had. A is 1, 2, and 3, okay? And then you would say, is that, and A is also 1, 2, and 3. So you could say A is a subset of B, but you would have to write A is not a proper subset of B. The way we write proper is not, is we make the subset symbol, the proper subset symbol, and put a line through it. Okay, that means not a proper subset of B. It is a subset, but it's not a proper one because the proper notation excludes the possibility that A equals B. In this case, A equals B, right? All the elements are the same. Okay, that being the case, this is not a proper subset. You would have to not have one of those elements for it to be a proper subset. Similarly, sometimes you'll see a symbol like this, a subset with a line this way, and a regular subset, and a line through it. That means not a subset. Okay? You want to see an example of not a subset? I'll give you an example of not a subset. If A equals R, F, and Q, and B equals Z and S, doesn't matter which letters I pick, okay? I'll say B is not a subset of A, okay? These elements do not come from there. Okay? Even if there was one element that did, even if I included an F, say, put the F in there. Okay? So, hey, wait a minute, F comes from there, right? But for it to be a subset, all of these elements would have to come from A. I hope that's clear. For B to be a subset of A, all of the elements of B would have to come from the set A, which is clearly not the case. So we indicate that by writing B as a subset of A, but put a line through the subset symbol to make sure that we understand that it's not. Okay, so we also have that the null set is 0, and we talked about the universal set. Okay, so those are concepts that we'll be looking at. Okay, so let's do a few problems. Okay, so given R equals the set 3, 6, 9, and 15, okay, make a list of all the subsets. Oh, okay, make a list of all the subsets. So just thinking about it, a subset could be any of these. I didn't say proper subset, so it even could be all of them, okay? So let's make a list. I'm going to need some room here. I hope I have it. Okay, let's make a list of all the subsets. Well, even if I don't finish, you'll get the pattern. You'll get to see how I'm doing this. Okay, so let's look at all the subsets of one element. Well, 3 is a subset, right? So is 6 a subset. So is 9 a subset. Okay, so is 15 a subset. Okay, these are all subsets. I could separate them with commas. This is a list of all the subsets of one element. Okay, I could also say that, so we don't forget about it, the null set, okay, is going to be a subset. Okay, and we can even say the universal set is a subset. It's going to be all of them, but we'll write that out. You know what? We'll write that out as a list of the four elements when we get to 4. But so far it's no elements, that's your null, 1 element. Now let's look at how many ways we can do 2 elements, okay? This is a little bit of bookkeeping. It's not higher math, it's just bookkeeping. Suppose I do 3 and 6, then I do 3 and 9, the first on that one. Okay, I do 3 and 15. Okay, is that all the sets of 2 at a time? No. I have all kinds of other things. What about 6 and 9, or 9 and 15? So I took the first one with each of the ones that follow. What if I take the second one now? This is groups of 2 still. 6, well, I don't have to go back to this because I have 3 and 6, 6 and 3, 3 and 6 are the same. We said the order of sets don't matter. Okay, so I'm going to have 6 and 9 because I don't have that yet. Okay, and I'm going to have 6 and 15. Okay, I don't have that yet. Am I finished? No, because what about 9 and 15? I don't have that yet, do I? So this is just bookkeeping. It's not higher math. I'm just trying to methodically go through all my elements and make sure I have them in groups of 2. Okay, so I have them in groups of 1, groups of 2, 0, groups of 2. Okay, now I have all the cases. You can't pick any 2 that I didn't have already. Okay, so I got that. Now what about groups of 3? Well, I'm running out of space. But the way you would do that, or you could use your own method if you want to make a little check-off list of some way. But what I would do is I would have the first one plus these 2, plus these 2, plus these 2. Okay, that's the only way with the 3 I can get 2 more. Then I would have this, the 6. Okay, and I would have 2 with that. Well, I guess I have to write it out because it's going to get very confusing, but I'm out of board. So maybe I'll leave that as an exercise for you.